This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic. This is part of a series of videos where we're going to be solving more complicated trigonometric equations where we might need to use these methods: factoring, the quadratic formula, or other methods for solving quadratics. We might have to use trig identities. We might have to square both sides. We also might be dealing with multiple angles. Keep in mind that anytime you square both sides of an equation, it's essential that you check solutions for extraneous roots. All right, we're going to solve this trig identity. Sine of negative x equals cosine of x. We're going to find solutions in 0 degrees to 360 degrees. The first thing I notice is I have the sine of negative x, and over here I have the cosine of x. So I am going to use the identity that sine of negative x is the same as negative the sine of x. So I have the same argument for each of them. Remember, sine is the odd function. Okay, now at this point, I don't see any other identities I could use. I could maybe try to set this equal to 0, but I don't think that's going to help me either. Not sure what I would do with that. So I'm going to think of another strategy. So one thing we could do is try squaring both sides and see where that leads us. So let's see if I square both sides. On the left-hand side, I'm squaring a negative, so it's going to be positive, and then I have sine x quantity squared. That's the same thing as sine squared x. And over here we have cosine squared x. Now, once we're to this place, there's actually a lot of different things that you can do. But one thing I'm noticing is it'd be nice if we had everything in terms of either sine or in terms of cosine. And anytime you have a sine squared x, you could write it as 1 minus cosine squared x. Similarly, anytime you have cosine squared x, you could write it as 1 minus sine squared x. And I'm going to try that strategy here. I'm going to replace this cosine squared x with the identity 1 minus sine squared x. I'm doing this because I'm thinking, how can I get them to be all the same, like either all sine or all cosine? It would look different if you had replaced the sine squared x, right? So just keep in mind, this is just one way to try solving this equation. So let's see. Now I have a sine squared x on both sides. So what I'm going to do is add sine squared x to both sides to combine the like terms. So that gives me 2 sine squared x equals 1. How about if I divide both sides by 2? So I've solved for sine squared x. Oh, and here's another method. How do you solve when you have something squared on one side? You could take the square root of both sides. So that's the next natural step for me. And when you do that, remember what you have to do. You have to put plus or minus. So plus or minus, the square root of the top is just square root of 1, or 1. And the bottom is square root of 2. Now, you could go ahead and rationalize the denominator, but hopefully once you see this, you recognize that that's the sine of a special angle here. That's that 45-degree angle, basically. But notice we want all the places where it will either be 1 over square root of 2 or negative 1 over square root of 2. So if you think about your possibilities here, we have that, this, that, and the other thing. Here we have all those angles. So when you solve for x, when you solve this equation, which is not the original equation, right? I squared both sides right at the very beginning, so this changes things. I get 45 degrees. Let's see, this one over here is 135 degrees. See, this one was 225 degrees and 315 degrees. But there's something really important to pay attention to here. Right here, anytime you square both sides, you must check solutions. You should always check your solutions, but you need to check them for extraneous roots. This means sometimes when you square both sides of an equation, you'll actually get some solutions that are solutions to your new equation, but not to your original equation. All right, so let's take the original equation, and we're going to have to check each one of these values for x. All right, so here's our original problem. Solve the sine of negative x equals cosine of x in 0 to 360 degrees. And we came up with these 4 solutions after we square both sides and solved the equation. So you have to check one at a time. So we have to plug in 45 degrees. So let's plug in 45 for x. So this would be, I'm plugging in 45 degrees. Right? And what's the sine of negative 45 degrees? Well, let's see, I don't memorize that. I know it's down here where it's going to be negative, and that's going to be negative 1 over square roots of 2, or negative square roots of 2 over 2. Now what about the cosine of 45 degrees? So the cosine of 45 degrees, you know what, that's a quadrant 1, so I know it's going to be positive, so these are not going to be equal, and in fact it's 1 over square roots of 2. So this tells us that this is not a solution, does not check. Okay, so we cross that off. Let's try 135. So we put the sign of negative, there's the negative sign, and we're plugging in 135 degrees. Okay, where is that? The sign of negative 135 is over here, right? Because you have to go in the negative direction, where the sign is going to be negative, because the y value over here, if you made the triangle, would be negative. So this is going to be negative 1 over square roots of 2. Okay. Now let's plug in 135 for x on the right hand side. Cosine of 135 degrees. All right, let's look at that picture. That's over in quadrant 2. Right? And in this quadrant is where the cosine is negative, and so it does end up being negative 1 over square roots of 2. So yes, this one is a solution. Okay, that one checked out. Okay, similarly, we have to check 225 degrees and 315 degrees. I'm going to let you do that. You do it exactly the same way. You would plug in 225 degrees in for x in the original, simplify the left-hand side, plug it in for x over here, check it out, and find out if that's a solution. And it's not going to be a solution. It's not going to check. You're going to have opposite signs again. And then 315 is the other one that will check. All right, so that's something that I'm hoping you can do. I checked the first two. You checked the second two. All right, so our solutions then, finally, are 135 degrees and 315 degrees after we check. Now, this is only one way to solve this equation. There's two or three other ways that came to my mind. So in the next video, I'm going to show you a different way that you might have solved it. This is your Math Gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic.